So welcome back to Aayu Pathshala, and we will continue with this video series. And today we will start with the physical layer, that is the bottommost layer of the OSI model, that is the layer number one, and we will understand what are the roles and responsibilities in this layer. Before that, if you are new to this, kindly subscribe to our channel, that is Aayu Pathshala. And the notes probably I will be uploading today itself on this Telegram channel, that is t.me/apdcio2025. You can search this and join this for the notes. Already previous videos notes are available in this channels. So let us begin with the physical layer. See, we have understood till now. I think we have developed sufficient background, and we have dedicated so much time in developing a background to understand the OSI layer. And finally, we are starting the OSI layer. So we know that the physical layer is involved in the transmission of data. Suppose this is the wired or some transmission medium, and here this is the physical layer. Basically, this is where the physical layer acts. We have seen this in the previous video, and I hope that if you're watching this video, then you must be aware that where do physical layer act and where the other layers act, as we have taken the practical analogy as well to understand these concepts. So physical layer where act as a transmission medium, and before that we have the data link layer, and also if data is being transmitted in this way, so for the receiver, and also we will have the data link layer at this end, data link layer. See, now understand, friend, in the data link layer, I don't know how is the data is coming for this moment. Let us understand that the data are packed in the frames. This is frame. Whenever I say a frame, it means that it's virtually it is the groups of bits. It is basically having a group of bits. This is the frame. A frame, just for now, for the moment, just understanding that a frame is a group of bits. So these groups of bits, when it will be transmitted, the physical layer ensure that these bits are this frame is basically each bit is transmitted sequentially or serially, like this. So the first very thing that the physical layer will ensure is bit transmission. Okay, it is not going to transmit the entire frame like this. It is going to transmit bit by bit, and we have seen that whenever the transmission is been done, it is done bit by bit only. So bit by bit transmission will take place at physical layer. Point number one. Point number two. Now we have also seen that this 10 is not transmitted as 10. It represented by some coding scheme, say RZ or NRZ or something like that. So this encoding will be also done at the physical layer. So bit transmission is done, encoding will be done. This bit will be encoded into signals, voltage signals, so that these signals could be sensed at the receiver end. Correct? Now for bit transmission, so can I say that the physical layer is also responsible for bit rate, the rate at which it can transmit the bit. It will depend upon the bandwidth of the channel, obviously, but this layer only sees at what rate or bit rate the data are being transmitted. Again, if we have in the previous videos, we have seen that the different topologies, that whether the communication is taking place in mesh topologies or ring topologies like that, that will be also the responsibility of the physical layer. That is what in what way the devices are connected. So these are like there could be multiple devices connected and transmission is taking place between them. So different topologies is also responsibility of the physical layer. So let us go one by one and see what is there. In the physical layer is the first bottommost layer of the OSI metal that we have already seen. It is responsible for the actual transmission of raw binary data 0, 1 over a physical medium. This layer does not understand meaning of data, only deals with signal, electrical, optical, or radio. Correct? That is why encoding is required to encode the signal. What are the responsibilities? Bit transmission is one of the responsibilities. Data rate control, that is bit rate. Okay. Physical topologies, we have already seen what are topologies. Synchronization, ensure the sender and receiver's clocks are aligned. Transmission medium, what are the transmission medium? That means that whether the transmission medium is like you are transmitting through a optical cable, or you transmitting through the copper with twisted cable, copper pair, or you are using the wirelessly transmitting it, or you are using a coaxial cable. So what sort of transmission medium? Basically everything related to transmission will come under the physical layer. So line configuration, it also check line configuration, that is point to point or point to multi-point. Encoding and modulation we have seen, and physical characteristics. So even if you do not remember all this, just remember those things. If they're in the questions, if it is given that which of the following is the responsibility of physical layer, just relate things that whether this is involved in practical transmission of the bits. If yes, that will be the responsibility of the physical layer, and it is the bottommost layer. So bit transmission, data rate control. From bit transmission, we can remember the bit rate control, physical topologies. Obviously, this is an obvious role. Then synchronization, transmission medium, encoding we have seen, and line configuration. Okay. So this was the physical layer for you, and the physical layer is the bottommost layer where actual transmission is done. So it does not care whether the like we have the physical layer over here, and above and below are what? Above the physical layer is what? Data link layer. Above to it is data link layer. So the data link layer must pass some data to the physical layer. So it does not care whether the data is being passed with like in a frame, or in a frame there are different header, or the actual data is not this part, actual data is contained here, and the ending is also not a data but it is a checksum or something. It does not care anything about it. It just sees that okay, the data link layer has given me this frame where I see only bits, only where I see bits. What the physical layer will do, it will transmit each bits serially, one by one, one by one. And how fast it can transmit, that will depend upon the bandwidth of the channel. Also, the how much bandwidth is available in the channel. And each bit, since zero cannot be transmitted, so it will obviously encode into some voltage signal, or that signal, therefore encoding will be required. So this is much with the physical layer. Now let us move to the most important layer, that is the data link layer, and most of the questions are expected to come from it only. So before we move to the data link layer, let us just quickly go through the nodes and see what are there in the physical layer. See, the role of the physical layer we have already seen, roles and responsibilities of the physical layer. Then transmission medium. Transmission medium can be twisted pair cable, that is the like the copper pair, coaxial cable. What is a coaxial cable? See, coaxial cable, you have seen the cable that was used in the dish antenna, when there is a like a central backbone to the cable, which in which there is a metallic cable is there, then around it there is a copper or say aluminium wires being wrapped all around it. That is used in the the DTH services, the cable that is called the coaxial cable. Then we have the optical fiber. Okay. So unguided medium and guided medium may be there. Unguided medium means wirelessly if you are transmitting the data, then it is unguided medium. And when you are transmitting it through some cables, then it is called as the guided medium or the wired medium. So it could be like radio waves, or in the microwaves, or infrared, or the satellite communication. Transmission mode could be serially, but see, in the physical layer, when you are transmitting it over the long distance, then serial transmission takes place. However, there could be a parallel transmission, but multiple bits is being transmitted once at a time, and that is being done by the bus. That is being done by the bus, serial bus or parallel bus, and that is occurred inside the CPU. So if you do not remember that the parallel transmission is being done, generally you remember that the serial transmission is being the major responsibility of the physical layer. Then the types of signal could be analog signal, digital signal. This I'm not explaining it because we have done this in the communication lectures. Encoding technique also, digital to digital and analog to digital, PCM, pulse code modulation. I discussed this in the chapter in the video number 1. Then multiplexing, FDM, TDM, WDM, and CDM. This we will see. That is when we move on to the data link layer. That the multiplexing is required to control the flow of the data. And also we have seen this in the communication part. So switching techniques, we have seen circuit switching, packet switching, and message switching. When whole message is sent and stored forward. In circuit switching, we have seen that a dedicated path is established, and in the packet switching, we have seen that the data splits into packets and then is sent independently. So now this finishes the physical layer. Now let us start with the data link layer, which is the most important. See, the most important layers in the OSI layers are three: D and T. That is the data link layer, network layer, and the transport layer. Most of the questions are expected from these three layers, and out of which data link layer is very much important among these three. These three layers are important altogether, but among these three, data link layer are very important. So now let us understand the data link layer, and have patience and listen to what I say, and you will be able to understand data link layer without having to like remember the things. Just you will automatically visualize this, that these things will be required at this layer. See the data link layer. When I say that the data link layer, what layer is it working between? This is the physical layer. If you remember the OSI layer, application, presentation, session, transport, network, data link layer, and the physical layer. So this is the way, that is this is the layer number 1 and this is the layer number 7. So physical layer we have done. See data link layer. Data link layer we are here also. So this is between the network layer and the physical layer. But we have seen that if someone is transmitting data, the transmission is done by 7 to 1 from the application layer to this layer, and then the receiver end, it goes on like this from 1 to 7. So if we write down that P, D, and T, S till here, we see that there are two data link layer present between the physical layer. One at the sender side, this is the sender one, and this is the receiver device one. And physical layer is the common layer, means that is the physical layer that is actually carrying the bits, or the signals representing the bits. rather to be more precise. So this data link layer is between what? Physical layer, since that is data link layer. So now if bit is being transmitted from here, there is a frame of bits. These bits are transmitted using this physical layer. So obviously there would be some errors in it. Why errors in it? Suppose from this point to this point it travels. So the noise could interfere in this. Obviously, in the communication part, we have seen. Suppose this is the signal. So this signals is the signals which represent for positive part, it represent one, or plus five magnitude represent one. The noise could come to it. And suppose this is a zero, which represents zero. The noise could interfere with it and make it like something like plus 3 volt. So that could be possibilities. So error could be here. So when these bits are received at the receiver end, the data link layer there, what will be the primary responsibility? Number one, it should be able to detect error because the bits are transmitted and we are not sure that it is an error free transmission. There could be error. Zero could be interpreted as one and vice versa. So the primary responsibility would be to detect the error. Number one, to detect the error and correct it also, and to correct it. Number one. Number two, now understand like this, that this sender is using the latest technology device, and this is the sender end and this is the receiver end. So the receiver which is at the receiver end is not able to, these bits are being transmitted as the like same speed. So there could be a speed mismatch between the sender and the receiver. The receiver is not able to like process the thing as fast as it reads. What at the receiver and what it will do? What it will do? It will receive this signal. So it has to convert back to 0101. That is decoding has to be done at the receiver end. But the receiver is not able to process that in a very fast manner. That means the speed at which the encoding is taking place and the bits are transmitted, the same speed the receiver is not able to process. It is either slow. In that case, there could be the flow control that is required between the sender and the receiver. And the next adjacent layer is the data link layer. So flow control has to be done here only, data link layer. So the next important requirement for the data link layer would be the flow control. Other important requirement could be like, see, also this is the like common medium, and there is not that there is only one sender. There could be large number of sender, sender one, sender two, sender three. There could be large number of receiver, receiver one, receiver two, receiver three, and each are waiting for the data to come. So it is high chances that suddenly or one at a time, sender two is also sending the bits. Like each device will be operating in OSI layer. So data link layer will be present here also. So these frames of bit will be, sender 2 will be also try to send on the physical layer or the medium, transmission medium, or sender 3 will also be try to send that same on the same medium. So their data collision could happen. Now, when we were talking about communication, we have seen that to avoid that, we will modulate S2 and S3 at different frequency, at different frequency. That is why we need the modulation. That could be done. That is a possibility over here. But actually, these S1, S2, or S3, these two signals are sent by like very long distance. So we do not know that if we modulate this at a particular frequency F1, so S2 is an independent sender. He may also modulate the signal in same frequency. So that is one of the possibility, but not the not the like proper or exact possibility in that case, in like in data transmission case. So what we have to do, like we have to develop some mechanisms so that we can figure out the data link layer of S2 and data link layer of S3 should communicate and see that only one at a time is transmitting the signals, and the second signal, the second sender will only transmit when the S3 has finished transmission. That should mechanism should be developed. So here we can say that the access control should also be done. The access control should also be done. Access control. So this is the three important roles of the data link layer. Other could be like, other important role could be physical addressing. Just remember this physical addressing. Why physical addressing is required? See, physical addressing means what? We now see there are two type of addressing we have seen in the above videos. That see, when we have understood the hostel analogy, we have seen that there is the logical addressing being done when we are labeling the packet as DD, and there is the permanent room number A2. So sometime, like if you are understanding D for Delhi, there could be high chances that I will bring a new methodology and I will say that DL will be now Delhi, not D. But the hostel is fixed and the room is fixed. It could not be changed. Similarly, logical addressing may change. Logical addressing may be assigned to one PC now. It may be assigned to another PC for after some time. But physical addressing is required because each computer having a MAC address, and that address is fixed. So physical addressing is required. to ensure the proper delivery of the packet to the exact address, and therefore physical addressing is the responsibility of data link layer. Okay. Now also framing. What is framing? See, now this data link layer above, before data link layer is what? Network layer. See, this is network layer, this is data link layer, and data is being transmitted from this side. This is physical layer, this is the sender end, this is the receiver end, then we have the data link layer, network layer. So obviously data link layer is receiving some message or some bits from the network layer. So, and it has to ensure that there should be error detection and correction mechanism, there should be flow control mechanism and access control mechanism. So it obviously it has to, like we have seen that when we were talking about that two devices need to communicate with the server, it added some information along with the data so that the server could differentiate. Similar fashion, the data link layer will be adding something like the protocols. We will see what is actually being done, but along with the data, like suppose this is the data that it has received from the previous layer, that is the network layer. So it will be adding something, some source of information in front of it and at the end of it. So this source of information will be required. Why? This source of information will be required for the performing these three functions. That is the error controlling and detection, flow control and access control. So this is known as the header. This is known as the header. Okay. And the entire combination, that is the entire new frame or new set of data has been framed, which is termed as frame. So at data link layer, when we talk about frame, it means the original data or the payload that it has received from the previous layer, that is the network layer. Along with it added some bits of information for other functions to be performed by it, and that bits of information together with the payload, original payload, is known as frame. So obviously that must be a standard frame structure so that every device could be able to understand that, okay, this first bit will be this, second bit will be this, third bit will be this. So there should be a standard frame structure, and this frame structure is known as the Ethernet frame. And let us see what is the Ethernet frame structure first. Ethernet frame structure. So in the Ethernet frame structure, let us see the what are the size of the frame structure. Say the size of the frame structure is variable, not fixed. Why variable? I will come to it on later part. First, remember that the size is variable. Also, we have like 26 bytes frame. That is the total. This is the header, total header length. Total header length of the Ethernet structure is how much? 26 byte. So 1 byte will be equal to how much bit? 1 byte is equal to 8 bits. Okay. So remember this, 1 byte is 8 bits. Now let us see what are the different frames of the Ethernet. So let me make, in the beginning of the frame, there will be preamble. Preamble. And preamble, how much? What would be the length of the preamble? Their length should be fixed to be like easily understood by the like by the all the devices that are using the data link layer. So it should be fixed, and that is obviously 7 bytes. Okay. Then we have the start frame delimiter. That is 1 byte. So this 7 byte preamble will be like alternating 1010101010. When such type of data you are receiving, alternating 101010, it means that the frame is going to come. It has not yet come. And the start frame delimiter after this, like we will receive 10101011. When you receive two consecutive one after a continuous stream of 101010, it means that now the frame is going to start. Actual frame is going to start. So this sometimes if we when we talk about the frame length, so we ignore this 7 byte plus 1 byte, 8 byte, we ignore this. After that, we have like destination address, DA, source address, SA, and each destination address means the physical address. That is the MAC address. So MAC address is basically how much? 6 byte. Remember this. Source address will be also 6 byte and destination address will be also 6 byte. Then we have the length field. The length field basically tell us that how much is the length of the frame. What is the length of the frame? And that is basically 2 byte. That is 32 bits. Sorry, 16 bits. We are talking in bytes, but actually in bits it is 16 bits. So now there would be a data, and then here we have the CRC, cyclic redundancy check, that is used for the error control. Okay. So this is also like 4 byte data. So now if you add the total length, it would be like 7 byte plus 1 byte plus this is destination address 6 byte, source address 6 byte, then length of the length of the frame, that is 2 byte, and CRC 4 byte. So it is obviously 12 plus 6 18, and plus 8 26 byte. So this is 26 byte frame. But the actual frame, what is the actual frame? This is just an indicator of the that the frame is going to start and when the frame start. But the actual frame is where we are starting from here. So actual frame is only 18 byte. The actual frame length is 18 byte. Okay. Now just see, this is the data. So data is also, there could be the maximum. You cannot like fit unlimited data over here. There could be like obviously you have to means fix the size of the data that you could send. So this is ranging around like 46 byte to 1500 byte. Just remember that 46 byte to 1500 byte. So if this is the actual header length and this is the minimum data length, so this could be like how much? 64 byte minimum data, minimum frame size. This is the minimum frame size, and maximum would be how much? 18 byte plus 1500 byte. That is 1518 byte. This is the maximum frame size. What is the maximum frame size of a Ethernet frame? That is 1518 bytes. Now see, this is the starting, and now let me make this frame like here to make it more clear. And this is the preamble. So I would not be making all the entires, but see, this is the preamble. It comprising of 10 10 10 10 something. Then we have the SFD, start frame delimiter, that is the delimiter, that is 0 10 10, and then 2 digit 1. Similarly, all the bits are there. 10, all the bits are there. These all bits are basically packed and into one frame, and then it is given to the physical layer. Now, when the receiver end, there is a data link layer we have seen. So at the receiver end, the data link layer will see what is coming. It is coming 10 10 first. This will go this way. 10 10 10. It will understand that okay, the frame transmission has started. As soon as it will receive 1 1, it will say okay, 1 1 means what? The frame has now begun. So from there, it will separate 6 byte first. That means 48 bits. 6 byte first, and see that this 6 bytes are the destination address. Then it will count more 6 byte. Okay, this is the source address. Then again, it will separate 2 byte, and then the data could be separated. This is the actual data, and this data will be passed on to the network layer. Receiver side also, that same layers will be there. So data layer received it and then separate that the actual data and pass it to network layers. Okay. So this is what actually being done. So we have understood what is the Ethernet frame. This is the Ethernet frame. Actual size is like 18 bytes. Total size is 26 byte. And the maximum and minimum data we have seen. So now, okay, physical addressing. Let us understand what is physical addressing. See, physical addressing, we have seen the destination and source address as how many bytes? 6 bytes. So we have, like, if you want to see the MAC of your PC, you just type ipconfig, and you see that there are the MAC address given. That is AE colon colon 12 colon colon 06 colon colon like BF, something like that. That would be 6 byte. This is how much byte? 4 byte. AP, so not P, D, and E2. This is the MAC address. This is called the physical addressing. Why it's called the physical addressing? Because in the frame, Ethernet frame, it is adding the physical address and the source address, the destination and the source address physical. That is the physical address of the source computer from where the data is being sent, and this the destination computer from which to which the data is to be transmitted. And why this is required? Because see, when the network layers will see, when the data link layers see that this is the destination address of the PC. So by the time this address reaches, and it will also have the network logical address that we will see in the network layer. The logical address will be there, which is called the IP address. So suppose that 201.12.26.108, like this type of IP address will be there, but this IP address is not fixed for a particular PC. It may change. So it will send this address, that is the physical address, to the entire network to find out where this physical address is present in the network. And the device that responds that this is my address, there is a protocol called as the address resolution protocol. We will see when we move to the network layer. So this, therefore, for this process to happen, this physical addressing is required, and that is to be done by the data link layer. So this data link layer will work both for both channels when it is wired or it is wireless. Wired also and wireless also. Just remember, for wired we have the IEEE standard, which is known as the 802.3, and for wireless we have 802.11. Okay, just this, remember these two standard. Okay, then we will end this video here, and in the next video we will talk about the other three important roles of the data link layer, that is the error control, flow control, and the access control.